Hello all, welcome to the series of linear integrated circuit. And this is the topic non-inverting operational amplifier. In previous class, we had discussed inverting operational amplifier with virtual ground concept, where we have seen that whatever voltage present at non-inverting terminal that was automatically reflected to inverting terminal because of ideal op amp considering gain as infinite. अगर हम गेन को इनफाइनाइट कंसीडर करेंगे देन वी कैन से कि दोनों टर्मिनल वर्चुअली शॉर्ट सर्किट होंगे वट एवर वोल्टेज is at non-inverting terminal that is automatically considered as inverting terminal. So now we are going to discuss about non-inverting op amp. So in previous class what we have seen in inverting op amp, this was the circuit minus plus. Quickly we can see the output of this one. This is inverting, this one is non-inverting. This terminal was grounded, this was V1, so V1 is equal to 0, and we have one resistance here that was R1. We can say R2, any kind of nomenclature we can use for this resistance. This was V input, and we have to provide a feedback, so there is a negative feedback, and this is the feedback resistance. This particular terminal voltage is V2 and this node is A. So this was VID that we have seen in previous lecture. So what we have output expression was minus of RF divided by R1 into V input. So we are getting this negative sign because there is a phase shift of 180 degree between input and output. So here now we are discussing about non-inverting op amp. So non-inverting amplifier, in this amplifier the external input will be applied at in this amplifier external input voltage is applied input voltage is applied at non-inverting terminal. And one more thing that the inverting terminal will be grounded, that we are going to write here. Inverting terminal is grounded. And we have seen in non-inverting amplifier there will be no phase shift between input and output. That means the output of non-inverting amplifier always in phase with the input. The output will be in phase. We can write here in phase with input, means there is a phase shift of at 0 degree. This will be the 0 degree. So this was the inverting op amp. So now we can erase this. This configuration that we have seen here. This is inverting amplifier. Now we are making non-inverting amplifier. So let's say this is the symbol of op amp. We have output terminal. This is positive supply VCC, and this one is negative supply VCC or VEE, and we have negative terminal that is inverting. We can erase this. This is V minus of VCC, This is inverting terminal, so this voltage is V2. This is non-inverting terminal, so this one is V1, and the difference of these two terminals, V1 minus V2, that is basically VID. So this is the difference of these terminals. We will connect a feedback resistance here because we are discussing closed loop configuration. So we have connected a feedback resistance. Let's say this is RF, and here one resistance is connected, that is R1, and we are grounding it. And voltage will be connected here at non-inverting terminal that we have written here. The voltage will be connected at this terminal. We will connect a voltage here, AC voltage. This is plus terminal, minus terminal, and this one is grounded. So now the input voltage is connected at non-inverting terminal. That's why this is known as non-inverting amplifier. So now we need to do the analysis of this circuit. This one is non-inverting amplifier. This is non-inverting amplifier. So now we need to do the analysis of this circuit. So here we can write that the current flowing in this R1 resistance is I1. The current flowing in this RF resistance is IF. And the current entering in this circuit is, let's say, I2. And we have infinite input resistance. That means this I2 current will be 0 because here the resistance is infinite. Here this resistance is infinite. This is called as input resistance. This input resistance is infinite, means these two terminals are isolated. V1 terminal and this V2 terminal. V1 terminal and this V2 terminals are isolated. That means there will be no current. There will be no current. Neither in this terminal nor in this terminal. There is no current. So at this point, let's say this point is A. This point is A. So at node A, we can write here at node A. At node A, here incoming current, we are applying Kirchhoff current law. Incoming current is I1 and these two currents are I2 and IF. So all the incoming currents are equal to the outgoing current. So we can write here I1 is equal to I2 plus this is IF, and this I2 current is 0 because of infinite input resistance. So we can write here I1 is simply IF. And what will be the I1? I1 is 0. This is 0 minus V2 divided by this resistance R1. This is 0 minus this V2 divided by this resistance R1. So we can write here I1 is, the voltage difference is 0 minus V2 divided by resistance R1 is equal to, similarly, what will be the IF? This IF current will be this voltage V2 minus this voltage is I2 output terminal, because RF resistance is connected between inverting terminal and output terminal. So that voltage difference will be V2 minus V output divided by RF. So we can write here V2 minus V output divided by RF. So let's say this equation is 1. So we have written this equation as 1. Now by applying virtual ground concept. So what we have seen, we have considered infinite gain. That means A is basically V output divided by VID, that means V1 minus V2. So here we can write V1 minus V2 is equal to V output divided by A, considering infinite gain for ideal op amp. Considering infinite gain, this will become 0. That means V1 is equal to V2. Means here, what is the value of this V1? This V1 is simply V input. V1 is V input. So here V1 is equal to V input. So whatever voltage present at non-inverting terminal, that is automatically reflected as inverting terminal. So V2 will also become V input. V2 will also become V input. This is by virtual ground concept. Whatever voltage present at non-inverting terminal, that is automatically reflected to inverting terminal. So now we can put this V2 here and here. So from equation 1 we can write, from equation 1, by putting V2 is equal to V input. So what will happen? 0 minus V2 is V input divided by R1. So this will become 0 minus, this is V2 divided by R1, and this is V2 minus V output divided by RF. This is V2 minus V output divided by RF. So this become V2 minus V output divided by RF. So we can write 0 minus V input divided by R1 is equal to, this is V input minus V output divided by RF. So now we are simplifying it like minus of V input into RF is equal to V input R1 minus V output into R1. So we want to get an expression for V output. So what we can say, इस आउटपुट को इधर ले आते हैं और इस इनपुट वाले टर्म को इधर ले आते हैं. So this will become V output into R1 is equal to V input R1 plus V input RF. So this will become V output is equal to R1 plus RF into V input. We are having R1 also. This R1 is here. So we can write V output is equal to R1 plus RF divided by R1 into V input. So we can write V output is equal to 1 plus RF divided by R1 into V input. So this is a very important expression. This is a very important expression for non-inverting op amp. So what we have seen here, output is 1 plus RF divided by R1 into V input. We remember here we have plus sign. Plus sign means there is this, what plus sign represents, there is no phase shift. There is no phase shift between input and output. So we can write here output is equal to 1 plus RF divided by R1 into V input. What is this? This is output voltage of non-inverting amplifier. What is this? This RF is feedback resistance. What is this R1? R1 is resistance at inverting terminal. What is this? This is input AC supply given at non-inverting terminal. So similarly, we can also write the expression for gain. Gain is A is equal to V output divided by V input. So this will become 1 plus RF divided by R1. This is 1 plus RF divided by R1. And we remember, this represents that there is no phase shift. If this is the input, so we will get this kind of output. This, let's say this is the time domain. This is T. So there is no phase shift, 0 degree phase shift. If this value is Vn, so what will be this value? This value will be 1 plus RF by R1 into Vm. So it concludes that in non-inverting amplifier, we will get the positive output. Positive output represents that there is no phase shift between input and output. And what will be the expression of gain? That is 1 plus RF divided by R1. RF is the feedback resistance, and this R1 is the resistance connected at inverting terminal of op-amp. So this is all about non-inverting op-amp. So thank you for watching, and in next video we will see unity gain amplifier.